there. Welcome to Elementary Statistics and Probability, a subject that helps us make sense of world using numbers, data, and a bit of logic.
Have you ever wondered how we predict the weather? How surveys influence big decisions? Or how likely you are to win a game? That's statistic and probability in action.
So, in this course, we learn how to collect, organize, analyze, and interpret data, and also how to measure the chance of events happening.
Good afternoon, everyone. In this subject, elementary statistics and probability, we're going to discuss about the counting rules. So, counting rules, also called the multiplication principle. The fundamental counting rule provides a way to determine the total number of outcomes in a sequence of events by multiplying the number of possibilities for each event. So, sa madaling salita, the counting rules is also called a rule of product. So, with here an example of counting rules. So, a student wants to choose outfit for school. They have 3 shirts, 2 pairs of pants, and 4 pairs of shoes. So the problem that going to find is to find the total possible outfits of a student wants to choose an outfit for their school. So there are 3 shirts, 2 pairs of pants, and 4 pair of shoes. So as counting rules, as stated that it is a multiplication principle. So it means a product or a multiplication. So we're going to multiply these 3, 2, and 4 of the outfit. So 3 shirts times 2 pants times 4 shoes. So it is equivalent to 24 different outfits.
So our next topic is all about probability and counting rules. Under the probability and counting rules, we have permutation and combinations. Both permutation and combinations are used to count numbers of ways to choose our objects from n objects, but key difference is permutation order matters while combination order does not matters. So we have here an example of probability and counting rules. So we have 4 letters A, B, C, and D. So for the permutation, we are going to arrange 2 letters from 4. So we have AB, AC, AD, BA, BC, BB, CA, CB, CB, DA, DB, and DC. So for permutation, we have 12 pairs. While in combination, we are going to group the duplicate letters like AB and BA to make them as one. So we have AC, CA, AD, DA, BC, CB, BD, DB, and CD, DC. So we have 6 pairs in combination. So we have here another example in permutation and combination. In permutation, we have a formula NPR, where N stands for the number of all elements and items. P is for permutation and R is for the elements that are chosen. So NPR is equals to N factorial over the quantity of N minus R factorial. So easily we distribute 4 because there are 4 letters. So P, 2 letters because there are 2 letters in 1 pair. So it's equals to 4 factorial over the quantity of 4 minus 2 factorial is equals to 4 factorial over 2 factorial because 4 minus 2 is 2. So the factorial of 4 is 4 times 3 times 2 times 1 over the factorial of 2 is 2 times 1. So we easily cancel the 2 times 1 into the denominator. So the 4 times 3 is 12. So the permutation in the first example is correct because we have 12 pairs. Here an example of combination. We have a formula NCR is equals to N factorial over the quantity of N minus R factorial times R factorial. So we distribute the value of n because 4, C, the value of r is 2 is equals to 4 factorial over the quantity of 4 minus 2 factorial times 2 factorial. So it's equals to 4 factorial over 2 factorial times 2 factorial because 4 minus 2 is 2. So the 4 factorial is 4 times 3 times 2 times 1, and the factorial of 2 factorial is 2 times 1 times 2 times 1. So we cancel 4 because in the denominator we have 2 times 2 is 4, so we can cancel the 4 in the numerator. So we have 3 times 2 times 1 is equals to 6, which is the combination is 6. Next is random variables. So when we say random variable is a numerical value assigned to the outcomes of a random experiment, it helps translate real-world randomness into something we can work with mathematically. So a random variable, it is a numerical value that represents the outcome of a random experiment.
We have two kinds of random variables, which is this discrete random variables, continuous random variables. So, discrete random variables takes uncountable values. In short, ang discrete random variables ay mabibilang, while the continuous random variables takes uncountably infinite values within a given interval. So, in short, ang continuous random variable is measurable. So, we have here an example of discrete random variable. First, the number of students in a classroom. So, paano natin malalaman kung ito ay discrete random variable? So, alam naman natin na ang students sa loob ng ating classroom ay ating mabibilang. So, second, the number of pencils in the box. And lastly, the number of COVID-19 positive cases in Laguna. So, now let's move on to continuous random variable examples. So, we have amount of sugar in a coffee. So, paano natin malalaman kung ito ay continuous random variable? So, ang ating ilalagay na sugar sa coffee ay hindi natin mabibilang. So, ito ay ating ma-measure. So, kung pwede, ito ay 1 tablespoon or 2 tablespoon. So, now let's proceed to the second example of continuous random variables, which is the body weight, and lastly, the speed of a car.
So, the last topic, it's all about the probability distribution. When we say probability distribution, is shows how the probabilities are assigned to all possible values of a random variables. Or it's a function that describe a ranges of values that randomly variable will take. Then, after that, we're going to plot it on a graph. So, our graph, the title is a probability distribution rolling a pair of die, which is this vertical line or our y-axis. It's our possible chance that random variable of x, and this horizontal line or our x-axis, it's the possible outcome of rolling a pair six-sided of die.
In this video, we learned that the random variable is a value that represents the outcome of a random experiment. We explored the difference between discrete and continuous random variables, and we saw how probability distributions help us understand how likely each outcome is. Using the example of rolling a first six-sided die, we show that each number from 1 to 6 has an equal chance of occurring, which is why each probability is. This was clearly seen in our probability distributions table and graph, where all the bars were the same height. Understanding the random variables and their probability distributions help us make the sense of data, patterns, and real-life situations involving chance.
And that's the end of our video presentation. We hope you now have a better understanding. Salamat sa inyong pagtanaw o pagpaminaw. Don't forget, in math, everything has chance, just like in life. This has been Group 5. Thank you and God bless everyone.